Welcome to Researchers Camp. In this program, we introduce the researchers from all over the universe. And today's researcher is Dr. Anomnath Somwan Sanaro, Department of Chemical Engineering of Chulalongkorn University. Nice to meet you.
Nice to meet you.
Anomnath. So let's start the interview. First of all, could you tell me what kind of research you are doing now?
Okay. My research work is polymer clay nanocomposite.
Okay.
Yes, and
this figure shows your current research.
Yes.
Okay, I will show it.
Okay.
Yeah.
So this is the polymer clay nanocomposite, and polymer clay nanocomposite is the nanoscopic of the organoclay that disperse in the polymer matrix. By putting the organoclay in the polymer, it can make the polymer to be stronger and have better gas barrier property.
Oh, really?
Yes, and how to make it is like when before putting the clay into the polymer, we know that the clay is a hydrophilic material, but the polymer is hydrophobic material. So we need to make it more compatible between mixing it. And for the clay, we can do the ion exchange reaction. So to make the clay to be an organoclay. And after that, we mix the clay with the polymer. And if this is the organoclay.
Yes.
And if we mix it and the polymer chain can intercalate between clay layers, we call it intercalated nanocomposite. But if the clay layers can delaminate and exfoliate throughout the polymer matrix, it's called exfoliated nanocomposite. And we think that this structure is the best. So we can obtain the high strength and also the good barrier property from this material.
Okay, so this is something like well mixed composite.
Yes.
Okay, very nice. And what kind of application is this technique for?
It's like making polymer clay nanocomposite. We can use it in automotive industry. Like for example, the interior in the car, also in the bumper.
Bumper?
Yes. So to make the car stronger.
Okay.
And also lighter weight. The weight is reduced.
Oh, okay.
And in the packaging industry.
Packaging.
Yes, we can make the polymer film, the plastic film, that is stronger and let gas pass through less than the pure polymer. So the gas barrier property is better.
So the technique is very useful for industry.
Yes.
It's very practical research, important research thing. So let's move to the next topic.
Okay.
What kind of natural technique you can provide to other researchers?
Well, one thing that I can provide a knowledge is rheology. The rheology is the study of the material, the flow and deform of material. So this knowledge that I have learned and worked with for a long time.
So this kind of knowledge will be applied to a lot of research fields.
Yes. For example, like food science or
Food science,
cosmetic.
Oh, okay. So do you have any other things?
Yes, the mixing technology.
Okay.
So how to mix the polymer with nano-particle.
You're professional mixing.
Well.
In nano level. Okay, thank you. And
also the crystallization process. So when we mix the nanoparticle in polymer, so the crystallization process change, and we have studied. So I think I have knowledge that I can share with others.
Okay, so you have a lot to give. Thank you. So let's move to the next topic.
Okay.
your future research thing, what kind of research you are doing, are you going to do in the future?
Okay, because right now my research field is polymer clay nanocomposites, so I use the natural clay.
Oh, okay. Natural.
Yeah, it's from natural, right? It's from nature. But I want to move from natural clay to use the silica. And then I want to make synthesized parts. So that is the, I can show you here.
Okay. This is what you want to try to make.
Yes.
Think?
That is
the sizes, paper, and this.
Cage.
Okay.
So this is the cage of the silica and
the center one.
Yes, the center.
Okay, this one.
That nanoparticle. Yes.
Oh.
I want to synthesize the nanoparticle, look like that, and change the the functional group to be compatible with many different polymer. So in this way, I can control the property of the nanocomposite much better than the polymer clay nanocomposite.
Okay, so because the clay is natural, it's difficult to control.
Yes.
So by using silica, you can modify or change the profile easily.
I can change the structure. Yes.
Yeah. Okay. So, what is the object of your future research? What?
The objective of my research is that I want to control the structure of the nanoparticle before mixing it with polymer. And then when I mix it with polymer, the polymer can have the much better property. Like I can control the strength and also the CTE, that is the coefficient of thermal expansion. So it means that when the temperature change, when temperature increase, and polymer expand.
Expand, okay.
Yes. So if I put the nanoparticle in, I can control the coefficient of thermal expansion. So the polymer will expand less than the normal, the pure polymer.
Okay. And if the thermal expansion rate will decrease, what kind of benefit you can write?
I'm thinking about the application in the electronics field.
Okay.
Yes, that if the polymer, for example, the adhesive, if it attached to the metal, and the metal usually it expands less, much less than the polymer.
Yes.
So when it attached to the polymer and it expands with different rate, so it can crack.
Yes, it will be a problem.
Yes, it will be a problem. So that's what I think.
Okay. So, and I heard that you have another objective.
Yes.
Research.
I also want to study the rheological property of this material, because now we can control the functional group of the nanoparticle, and then when we mix it with polymer, the rheological property can be different, and we want to study the basic science in this.
Okay. So you will do some applicational study and the basic study in one topic.
Yes.
Okay, that's very fine. So the last topic, to achieve your future research, what kind of resource you want to get from other researchers, people?
Well, I think one thing that is a big problem in making nanocomposite is how to disperse the nanoparticle in polymer matrix.
Okay.
So if someone
knows that kind of technique, please tell us. And do you have anything?
Well, also is that if anyone who has expertise in nanocomposite, I still need an advice.
Okay, so please tell us. Thank you. So this is all of today's interview. Thank you very much, Dr. Someone Saunaro. So see you next time. Bye bye. Thank you very much.